Good evening, guys. Professor David J. De Los Reyes. My topic this evening will be a special case. The main topic is actually integral calculus. This is regarding volume. I want to discuss the so-called derivation of the formula for the volume of the frustum of a right circular cone using miscellaneous solution. Meaning it is not under circular disc, it is not under hollow cylinder method. For this evening, it will be a miscellaneous special solution. It seems it is under solid mensuration, the derivation of the formula for the volume of a frustum of a right circular cone. Okay, let's proceed. This will now be my lesson number 75, integral calculus, but this is a special discussion or topic tonight. It should be the hollow cylinder method, the frustum of a right circular cone. But for the meantime, I will not discuss the hollow cylinder method. I will discuss the miscellaneous solution. Miscellaneous solution meaning it is not integral calculus, but it is related to volume. Okay? So other bloggers are discussing the computation of volume, but they are not introducing integral calculus. So for the meantime, I will try to derive the volume of frustum using the special solution, meaning miscellaneous solution. Okay? I will try to read the problem. Derive the volume of the frustum of a right circular cone using miscellaneous solution. Miscellaneous solution, it is under solid mensuration. So all your knowledge of solid mensuration and the so-called derivation, you should use it. Okay, let's try to bring out the figure. We'll try to draw the frustum of a right circular cone on the Cartesian coordinate system. This is the y-axis, this is the x-axis. Okay, I will draw the right circular cone as a complete one. Then I will try to cut the right circular cone in here. So what will come out is actually a frustum. Okay, but why did I include the top portion? I include the top portion because the top portion is actually part of the solution. To make the solution simpler, okay, I included the top portion. Supposed to be the top portion is not there because we are only discussing the volume of the frustum. But in order for the solution to be more easier, we include the top portion. Okay, there is a purpose why we include the top portion. Okay, let's try to bring out the solution. If we try to project these triangles here, we project it on the right. Actually, we could create two right triangles from this. Okay, the upper right triangle is this one, and the bigger upper triangle is the complete one. This is h. This is equivalent to this. It is capital letter H, meaning the total height of the right circular cone, okay, including the frustum and the top portion, is capital letter H. This is H. The bottom portion is actually big R, the bigger radius of the frustum. This is the lower one, this one. And this one here is actually small letter r, the top radius of the frustum. Okay, that's it. The big R is this one. We just project it and draw it on the right. Okay, then we try to designate the other sides. If this is this point on the frustum is actually with coordinates R and H. So meaning this is R and this height is H. Okay, with respect to the horizontal, this is H. So this is actually H. From this point here to this is H. the upper portion should be capital letter H minus small h. Because the total height is capital letter H, the lower height is a small letter h, so this portion here is capital letter H minus small letter h. So this is capital letter H minus h, this is R, this is capital letter H, this is capital letter R. Theta, theta, okay? There is a purpose why I drew that one. I drew this one because later on I will try to formulate a relation of the terms, okay? Or a relation of the small radius, big radius, the altitude of the frustum, and the total altitude of the cone that involves the frustum, okay? This right circular cone is the top portion. Hold on, I will get my note. Without the bottom portion, this is the cone. Okay? Considering the big cone, from this point up to this, that's the cone. Okay? So as you can see, to compute for the volume of the frustum, we must have to take the volume of the bigger cone minus the volume of the smaller cone. Okay? Bigger cone, smaller cone, we try to subtract the volume of the bigger minus the smaller. That's the required volume of the frustum. That's the one we are looking for. Okay? Actually, we are looking for the volume of the frustum as a function of small letter r, big letter R, and small letter h. Because volume, it involves 3 unit lengths. Small radius, big radius, and the altitude of the cone. Unit length, unit length, unit length. So this is actually a cubic unit length. We will try to derive this one. Okay. We take the tangent of theta using the smaller right triangle. It should be bigger. It should be h over r is the tangent of this angle here. H over r equal to the tangent of the upper angle theta, which is the same as the lower angle theta. This is capital letter H minus small letter h over r. And in here, I didn't show you the simplification. But if you try to compute for the value of, why did I compute for capital letter H minus small letter h? Because I want to compute for this height here. Because in the computation of the volume of this one, I need this height. And from our figure, it should be capital letter H minus small letter h, okay? Okay, let's try to bring out the solution now. Volume number 1. Volume number 1 refers to the volume of the upper cone. The upper cone. And this is actually, we know that from solid mensuration, 1/3 pi times radius square times the height of that cone. So the upper cone, this upper smaller cone is actually, I designated with the subscript 1, this is 1/3 pi r square. The radius of the smaller cone is small letter r. So this is pi r small letter r square times its height. But we derive already the relation of its height. That is capital letter H minus small letter h, and this is actually the value. Okay? And if we try to multiply this one, volume number 1 will be 1/3 pi h small r cubed all over big R minus small r, equation number 1. So actually, we are now given volume number 1 as a function of h, r, and big R. Okay? Volume number 2. Volume number 2 is actually the volume of the total cone, the bigger one. It should be same formula, 1/3 pi. The radius of the bigger cone is actually capital letter R. So this is capital letter R square. Okay? Times, what's the value of H? Capital letter H minus small letter h is actually HR over R minus R. Right? We are solving for capital letter H. So if we try to transpose this one on the right, this is plus H, we could remove this one now. Okay? And that is capital letter H. And what is that capital letter H? Capital letter H is actually the total height of the bigger cone. It is this. Okay? So if we try to substitute this one back here, it will be HR all over R minus R plus H. Okay, I didn't show you the complete simplification of this. It is just pure algebra. What will come out for volume number 2 will be equal to 1/3 pi H big R to the third power over R minus R. Okay, equation number 3. So to compute for the volume of the Frustum now, this one. It should be the volume of the bigger cone minus the volume of the smaller cone. So volume subscript F refers to Frustum will be B2 minus B1 equal to, it is just a matter of substitution. B2 is actually 1/3 pi H capital letter R to the third power over R minus R minus 1/3 pi H small letter R to the third power over R minus R. Okay, then we try to simplify this one. It is just pure algebra, guys. I didn't show you the complete, what they call the simplification of this. But if we try to simplify this one, this will come out as 1/3 pi H over R minus R. Okay? This is big R cube minus small R cube. Actually, we could bring out pi H, common factor, right? Even the 1/3. So this is 1/3 pi H over R minus R, R cube minus small R cube. And if we try to divide big R cube minus small R cube over R minus R, what will come out is this one. You divide this one, the longhand division. What will come out for the equivalent of R cube minus small R cube divided by big R minus R? It will be big R square plus small r square plus the product of big R times small r. And that's now the final formula for taking the volume of a Frustum by using a miscellaneous solution that is under solid mensuration. It does not involve integral calculus. Volume of Frustum in general now will be 1/3 pi H times the quantity big R square plus small r square plus the product of big R times small r, cubic units. Okay? I think I derived this one already using integral calculus under the circular disk method. That is the volume of a Frustum is actually 1/3 pi H times the quantity big R square plus small r square plus the product of big R times small r. Okay, I will try to bring out the proof that if we try to divide this thing here, what will come out is this. It is this. Big R cube minus small r cube divided by R minus R. Oh, it's a longhand division, guys. Big R square times big R, that will be big R cube. Okay? This portion will be 0. Okay? And small r times big R square is minus small r times big R square. Then the operation is subtraction. R cube minus R cube will be 0. Minus R cube minus 0 will be minus R cube. Minus R cube, the operation is subtraction. This will become plus small r times big R square. And the next dividend will be small r square. What will come out if we try to divide, multiply small r square times the quantity r minus r? It will be minus r cube, small r cube, minus 0 plus small r square times big R. Then the operation is subtraction. Minus r cube minus minus r cube, this will become plus. This minus is plus, so the subtraction will be 0. Okay? There's a significance of the negative sign, because the negative sign, this negative, it will become plus. But this is minus, so when you add it, it will be 0. Okay? Minus 0. plus the next term will be small r squared times big R. If we try to multiply this one by this, okay, what will come out? Oh, the next dividend will be big R times small r. Okay, it will be plus small r big R square minus small r square times big R. Okay, this is the next dividend. If we try to multiply this one by this, what will come out will be small r big R square minus small r square big R. And the operation is subtraction, right? Okay, this is plus, this is minus, it will be 0. Okay, this is minus, but this is minus, but the operation is subtraction. So this is minus, this is plus, the resulting sum will be 0. So actually, after dividing it, the remainder is 0. And what is the significance of the remainder 0? Meaning, big R cubed minus small r cubed divided by big R minus R is actually big R square plus small r square plus the product of big R times small r, and it is this. You see, guys? Oh, this is a special case of the so-called derivation of the formula of a Frustum by using miscellaneous solution. It's not integral calculus. Maybe the next time around I will try to derive the formula of the Frustum using the hollow cylinder method. Okay? Then we could proceed to the last topic on the integral calculus, that is under the circular washer method on the computation of volume. Then after that, we do special figures, special volumes, and that's it. Then we could proceed with the next topic on my channel, differential equation. Okay, good evening, Los Angeles.